Okay, you guys go ahead and stop. Okay, so I just wanted to just check you guys out to see how fast you guys can kind of complete this. How many of you guys actually completed the front and the back? Okay, guys, decent amount, good. Okay, so just kind of just a way of me just kind of gauging where you guys are at right now, just kind of just seeing how well you guys were going through this and how fast you guys got through it. Let me go ahead and I want you guys to go ahead and take a look at the back side, which is Chemistry Quiz 4. Now I'm going to go over this with you guys, and just want you guys to kind of pay attention just to see where you guys are at knowledge-wise, and then we're going to go over the back side. But on the back side, I'm going to ask you guys to do something a little bit different. But just go ahead and take a look at Chemistry Quiz 4, that side over there. Okay, number 1 says, if the atomic number of Be is 4 and the atomic mass number is 9, how many electrons are there? If the atomic number is 4 and the atomic mass number is 9, how many electrons would there be?
4.
It'd be 4 electrons. Very good. Piece of cake. Number 2 says, how many electrons can fit on the second energy level of an atom?
8.
It's 8. Very good. Number 3 says, if the element Li has an atomic mass number of 7 and an atomic number of 3, how many neutrons are there?
4.
4. Perfect. Number 4 says, Mg has the numbers 12 and 24 associated with it. 24 is the atomic number. Is it the atomic number or the atomic mass number?
Mass.
Very good. So if you had, just for those of you guys that are visual, you got 12, you got Mg, you got 24. Just always keep in mind, the bottom number, which is the larger number, is the atomic mass number. Top number is the atomic number. Okay, number 5 says, Mg has the numbers 12 and 24 associated with it. 12 is going to be the atomic number, piece of cake. Number 6, using dimensional analysis to convert your age from years to seconds, show your work below. Okay, so with dimensional analysis, I'm hoping that every single one of you guys got number 6 correct. I'm pretty sure most of you guys got that correct. But I'm going to go ahead and work on number 6 on the board. You guys just pay attention to see how I do if you need a quick refresh. Keep in mind, this semester, we're going to be using dimensional analysis quite a bit, because dimensional analysis is going to be on your guys' tax tests. Alright? So just pay quick attention right over here. Just going to work it out real fast. This is something you guys should already know. You guys should have this ingrained into your head. If you guys don't, get it ingrained one way or the other. But I'm going to work it out real fast. You guys compare it to see if you did it correct. Okay, with dimensional analysis, first thing you want to do, you want to convert your age from years to seconds. So you're starting out with years, you want to end up with seconds. Okay, so with my map, I got years here, want to end up at seconds. All I need to do is connect years to seconds, just by breaking down years. Years can break down into...
365 days.
Perfect, can break down into days. Some people put months. How many of you guys put months? Years can break down to months. Okay, let me ask you guys this. If years can break down into months, let's think about it this way. How many days are in January?
31.
31. And February has 28 or 29, depending if it's leap year. March has 31, and then April is going to have 30. So you guys going to see how the months have various days in them. They don't match up with the days, so you can't use months. So let's go ahead and just break it down to something that's concrete or that doesn't change. Days, there's always 365 days in a year. That never changes. Months, the number of days in months, it varies from month to month. So we're going to break it down in days. Years breaks down to days. Days breaks down into hours. Perfect. Hours can break down into minutes, and minutes breaks down into seconds. Okay, this is my map. All I need to do now is just draw my brackets. What's the first thing I do? Label. Want to label first. Starting out with years. Since years is here, diagonal to years, I got years. It's been kind of messy. We can do real fast. Days. So we put D for days. D for days. Hours. Diagonal to hours. Minutes. Start with minute right over here. Cross that out. Diagonal to minute, I'm going to have minutes. End up with seconds. Now all I need to do is plug in my numbers. If you're 16 years old, 16 goes right here. Days and years. How do I connect days and years?
365 days on top.
Okay, perfect. 365 days at the top, 1 year at the bottom. Okay, hours and days. How do I connect that on this? Hours and days. How do I connect hours?
24 hours in 1 day.
Perfect. 24 hours in 1 day. Very good. 24 hours, 1 day. Minutes, 60 minutes, 1 hour, 60 seconds, 1 minute. All you have to do is multiply straight across. If you're 16, your number should have been 504 something, 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 something. Alright? Okay. Now, with dimensional analysis, you guys are pretty much... We're going to be hitting up dimensional analysis quite a bit in this class to get you guys ready for this semester and this tax test that's coming up. Now I want you guys to go ahead and take a look at the back side. Go ahead and turn your papers to the back side. I want you guys to go ahead and pull out your whiteboards, and I'm going to see how well you guys can draw. gonna see how well you guys are gonna be drawing, because you guys are gonna be doing some drawing in this class this semester. If you guys need a marker, raise your hand. If you need a rag, whiteboard, raise your hand. Okay, markers. Need some markers. If you guys have two more markers or two more whiteboards, just raise up the extra one. Okay, everyone got whiteboards, markers. Okay, on your whiteboards, what I want you guys to do, first thing I want you guys to do is, I want you guys to illustrate a beaker. After you illustrate what a beaker looks like, I want you to flip your whiteboard over and make sure nobody looks. I want you guys to illustrate what a beaker looks like from memory. Go ahead and illustrate what a beaker looks like. And I want you to hide it as soon as you get it. Because people are going to be looking around, you're going to see some prying eyes. Hide it. Ooh. Want you to hide it? Don't show it to me. Hide it.
That's a measuring cup.
Want you guys to illustrate a beaker. Okay, I want you guys to... We don't want you copying. Don't show it to me yet.
Stop copying, Colby.
Okay, so I want you guys to go ahead and raise your whiteboards up. Let me see what you guys got. Pretty good. Okay, so. Okay, so take a look at the front. This is what the beaker should look like. Something like this. That's a beaker.
Hey, something like this.
Okay, now, you guys take a look at this beaker right here. Let me ask you guys one question. This beaker, eyes to front, no talking. Eyes to front. Okay, now, with this beaker, let me ask you guys a question. What's the unit of measurement that is used with a beaker? Milliliters. Now let me ask you this. Pay attention to that. Does a beaker, does it measure mass, grams, volume, or measure, what does it measure?
Volume.
Measures volume. So what I want you guys to keep in mind is that every single time you guys measure something out in milliliters, they're asking for volume. If I ask you to find the volume of this liquid inside this beaker, I'm asking for the volume, which is the measurement, which is going to be in milliliters. Milliliters. Okay, and that's a beaker. Now, let me ask you guys this. You guys take a look at letter B. Letter B is a flask. Let me show you guys what a flask looks like. I'm pretty sure most of you guys know what a flask looks like, so I don't want you to draw it. I just want you to look. That's a flask. That's a flask.
It's a flask.
That'd be a flask too.
People that drink out of, they get drunk.
Yeah.
That's a flask. That's not that type of flask.
Oh.
A chemistry flask, not a drinking flask. Okay, 4C. Now, this is where a challenge comes in. I want you guys to illustrate exactly what a graduated cylinder looks like. I'm talking about getting the measurements and everything based on memory. Now, before you write down, let me tell you what I'm looking for. First time I asked you guys to illustrate a flask, you guys just drew pretty much something like this, which is fine. Now I want you guys to illustrate a graduated cylinder, exactly what a graduated cylinder is like. If you can remember the unit of measurement that it measures up to with a graduated cylinder, I want you to put in all those notches correctly as well. So I want you to draw a graduated cylinder exactly how you remember it being. I'm asking you guys to do this for 2 reasons. First reason is you guys are going to be using a lot of graduated cylinders this semester because graduated cylinders give you a precise measurement. That means that it gives you the exact measurement with what you're going to be wanting to get, because we're dealing with lots of different types of chemicals, experiments. We actually got a lab coming up next week that's going to deal with you guys using a graduated cylinder. If you don't get it correct, this experiment is flammable, so I don't want you guys getting hurt. So I want to make sure that you guys are good on this. I want you guys to draw exactly what a graduated cylinder looks like. Correct notches, correct measurements, correct everything. As much as you can. I want you guys to copy or write down this graduated cylinder. Seeing some good work here?
I got that.
Okay, I want to see what you guys got. Go ahead and raise it. Let me see what you got. Okay. Okay, looks good. I'm going to talk to you about the measurements.
Oh, it's wrong.
No, you got the shape right. I'm going to talk about the measurements.
Well, it's about measurements wrong.
Yeah, it's measurements. Okay, you're on the right track. We're not ready. You're pretty good, Michael.
Wait, wait a minute.
Okay, good. Okay, Dejan looks more like a beaker. Good. I'll tell you guys about the measurements.
Excellent. Yours is what's up, man. Smoke clean up. Thank you. Like a bomb.
Okay, I'm going to use Okay, so Mr. Lopez. Okay, so this is a graduated cylinder. Yeah, it's pretty good, right?
ML.
Okay, now, okay, before we get deeper, before you guys get thrown off here, this has the correct shape, but I'm looking for the correct notches, the correct measurements. So this over here looks almost the same. This is a graduated cylinder. And graduated cylinders, I want you guys to keep this in mind, that it goes up to 10 milliliters. So it's going to go all the way from 0 milliliters to 10 milliliters, and it's going to be in increments of 10. What does that mean? It's just going to be 1, 2, 3, or in other words, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So in other words, it's going to look like this. You got a 10 right here, and it's going to look like this. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's measured in milliliters, and it goes in increments of tens. Or pretty much it can be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So that's 10 milliliters. Okay, now, for this over here, for y'all's experiment next, you guys are actually going to be doing one next week. It's going to be dealing with, we're going to be dealing with different types of elements that burn. Alright, so you guys are going to be titrating once again. Last class, you guys did really good with your titrations. Huey's flew the highest. If you guys remember with the tea bags that flew, some of y'all didn't even fly.
Rematch?
Maybe a rematch. And some of y'all's, Huey pretty much, out of all the classes, Huey's went straight to the roof and it pretty much touched the roof, correct? So I mean, that was pretty good. That means that Huey, his titrations were right on point. That means that some of you guys may have done 275 drops, but your 275 drops might have been different sized drops. You get what I'm saying? What I mean is that even though every single one of y'all may have had 275 drops, one drop of the water or the unknown might have been bigger than the other drop. So that's kind of what maybe thrown some of you guys off. And Huey, he came the closest to having all his drops pretty much the same size. So for example, if he had a dropper and he's making drops of liquid on a table, his drops are pretty much going to be equal in size. Whereas some of you guys might have a drop that's kind of bigger than the other one. like this, that's going to throw off your titration. Okay, so with this titration, next class period or next week, you guys are going to be doing an experiment that deals with working with these types of drops. We're going to be doing an exercise before then to make sure that you guys are pretty good with your hands. And I got a dropper for every single one of you guys. We're going to be doing that next class I'm shooting for to get you guys good on that. Okay, now, for y'all's next instrument, I want you guys to go ahead and take a look at a pipette. Just go ahead and illustrate a pipette real fast, what a pipette looks like. What does a pipette look like? Yeah. Good. Good. Perfect. You're perfect.
And that was good.
Oh, okay, I know it.
Perfect. Perfect.
You do a crack pipe.
Yeah, it looks like that. Perfect. I'll show you yours.
Talk about your drug addiction.
We need to talk to the class.
Intervention.
Yeah.